So I am going to do a bi-rail sweep. Top rail, bottom rail, section, 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 section. Now, I don't think this is going to be enough information. I think I'm going to get an unpleasant result. But always do the fastest way first. A close sweep. Actually, that doesn't look bad. It's okay. It's all right. So I'm going to accept that. Join those together and put a cap on the bottom. Solid cap planer holes. And this should now be interesting. That didn't join. Try again. I want to join that surface. It won't. It says no. So there's some minor incompatibility. So join SRF. Just type it in. Join edge. Sorry. Select that edge. Select that edge and say yes. Same thing over here. Say yes. Same thing over here. Say yes. So there was about a 0.03 variance there. You can actually see it right here. Now those gaps remain. And it's still calling an open poly surface. So I can decide right now, class, with this just being a maquette, do I care that it's leaky or not? I kind of do. So going to undo the joint edge, and I'm going to undo the loft, or the bi-rail sweep. I told you I'm afraid there wasn't enough information there, and I was right. So end only. I want control here. And the question is, see how that doesn't quite line up with the extruded surface? You know, it's the old measure with a micrometer or mark with a crayon, cut with an axe thing. Which one do we want? Because this should have been good from the front view we had. And yet there are differences. I'm going to untrim my surface. I'm going to pull this curve onto the surface. I'm going to zoom in to see if it makes a difference. Yes, it did. So that happened. All right, so now I have, and yet still, look at that. Still a problem. So I have to decide if I'm playing with curves or surfaces, or if Rhino's going to care. But for right now, I'm going to draw that from the end of that surface. Mirror it around. Going to explode this. And bi-rail sweep. There are two separate edges here. Analyze edge tools, merge edge. Merge edge. And again. Surface edge, curve, 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 curve. Surface edge, curve for the two rails, section, section, section. Mirror side to side, mirror front to back, join. Cap planer holes. Closed. Okay, it seems tedious to go through those extra steps, but you always want to know what your geometry is. Is it an open poly surface? Is it a solid? Because I'm about to do a Boolean on this, and if it's an open poly surface, the Boolean may or may not work. When I try and take curves off of this to draw, if there are gaps, I'll get two lines. It's subtle. It won't really matter. I could have gone without doing this, but I model with a high level of hygiene when I'm working. I can't stand to move forward if there are significant problems of any kind in the geometry. So I've got these. I'm going to take all these curves in case I want them again someday. I'm going to group them together and I'm going to create a layer. Called storage curves. And in my file, storage curves is always a really dark green. I did not mean to group that one in with them. And change them to that layer so that now if I ever want them back, I know where to find them. And I put these at the bottom. So I have the main block. Now what I need to do is determine, I have already decided I like 1.5 millimeters here. I like that. And I have my finger bore there. What I did last time is I created a window box that would trim everything out. I'm going to do a little different thing this time. I'm going to offset the curve. I'm going to offset it 1 millimeter. And I'm going to do the scale just like I did last time. So it flares up wider at the sides. I'm going to extrude these two outward. Need front C-plane so I get a nice straight extrusion perpendicular to the C-plane and hit enter. Now at some point, one of you guys out there are going to do this and keep the top C-plane the same. You're going to do it because you're in a hurry. You're going to go, look at that. That jerk. I don't have to change C-planes every time. If you have a closed planar curve, usually you don't. Usually Rhino will figure out what C-plane you wanted based on the planar nature of these curves. But it's not 100%, guys. And you'll be modeling along and you'll make a mistake and you won't know why. So that's why I constantly just, once again, the hygiene, I change the C-plane before I extrude so that I know I'm getting an exact extrusion. I'm going to copy these, paste them in, group them together, create a new layer, call this storage objects. I already have one of those here. I didn't realize that. It's right there. I just called it storage. So actually, I'll delete that. Come back to storage. Give it the full name. Also move it down to the bottom and put these objects into storage. I do that because once I Boolean them, I won't be able to get them back if I don't. Boolean difference, throw the bottom away. Oops, wrong way around. Solid Boolean difference, delete no. It's not going to give me what I want either. So, sorry, solid intersection. That gave me what I wanted, but I lost my main block. I don't care. I'm going to copy this to clipboard, undo, paste it back in, throw that away. Now I've got what I want. I'm going to take this surface off the top. Right click on explode, copy equals yes. Make it a color that's easy to see. Don't want those, I want this. Gonna untrim all. Gonna offset -1.2. And enter. You have to hit enter twice. I don't really ever understand why Rhino does that, but it does. So there's my 1.2. I'm going to take a look quick, because at the end of the day, I think that's heavy. I'm going to offset at 1.1. -1.1. I like that better. I have no use for that surface, going to throw it away. I'm going to Boolean this with this surface, but I want to keep the top piece. So I want to make sure that the direction of my Boolean cutter points towards what I want to keep. So analyze direction. And it is pointing towards what I want to keep. Great. If it weren't, and I did a Boolean difference, it would keep the bottom piece, and I don't want that. But in its original orientation, cuts that off nicely. And there we go. Okay, so this is my new maquette. Copy that. I'll copy this to clipboard. And then I'm going to actually copy all of them to clipboard. Control C. And then I'm going to Boolean union this and this together. Put this on the same layer. And group these together. So I have this maquette ready for future reference. Paste them back in. That's interesting because I had copied all of these. So copy these two. Paste them back in. And I will put these in storage. Paste them in again. Deselect the shank and throw away the bottom plate, because what I want to do now, for comparison, and I already have these in storage, so I don't have to make a copy. This way I can compare the two excuse me. By the way, this is why I set my grid to 10 millimeters. I only ever use the grid for moving things. And if I move them using the grid, I can always get them back where they were. That's the only purpose I've ever found for using the grid, to be honest with you, so that I can move things away and move them back. But this gives us an opportunity to compare our two maquettes. Notice how much sharper the angle is here, how much more gradual it is, particularly from the side. Notice how much more ample our bottom plate is. Notice how much smaller the window. It's still a big window, but if you compare the airspace between the bottom of the under bezel and the shank to the under bezel and the shank, this is tighter. So this is what I want. So I'm going to grab these and move them over. So this is obviously closer to what I would like to have. So this is the model that I will actually now turn into my final maquette for my further design work. And to do that, I will temporarily Boolean union these together. Actually, nothing's at 0, 0, which doesn't matter. It just drives me a little crazy. Better. Okay. So I'll temporarily Boolean union this, because as we discussed last time, it gives you a better drawing. So, dimension, make 2D drawing, 4 views, USA. Okay. Now, unfortunately, actually, we have the drawing layer already used for other drawings. They're still selected here, so I'll just group them. I'll delete those. And once again, I'll ungroup these so I can take that out and regroup them, because I'm not going to like that 3/4 view. And now I'm going to set up a 3/4 view that I like for this ring. Put a sphere in the center. Now I can also put the sphere, it's a tip, I'm going to do it differently this time just to keep things challenging. Once again, I'm going to put it at 0, 10 millimeter diameter. But if I do it here, it's going to make the ring bore actual size. For our purposes, the stones might be more important to have actual size. So I will move it up to here. Turn it off while I decide the angle. I really do want to see those windows. But as I'm designing, I might also want to see more of the side shank. So I'm going to go with this. Group those together. Add in the ball. Group those together. Tidy things up a little bit so I can see better in the top view. So I have my two drawings here. I'm going to grab both of these and move them over to the side. One of them has the sphere, the other one doesn't. I'm going to draw the sphere back in as a line, drawing, at 0, 10 millimeters. Going to grab the piece with the sphere. Now it's going to be a challenge because down on the ring board the sphere always stays clear. But up here it doesn't. Copy no scale 3D. I've got a quadrant here. And for the spheres, the quadrant's all you can use. I don't have another quadrant, okay? So what that means is I'm going to have to approximate. And that's okay because 3/4 views are always an approximation anyway. Gauge near snap. Somewhere in there. It's close enough. So that'll give me the actual size. Orient again. This time, pick 2 points that I can see in both drawings. Throw away the one with the ball. Move this into position. Move all of these into the center. Put an outline around them. Once again, just using to create a buffer. Make sure I'm in the orthographic top view before I export these out. Call it maquette, revised. That's good. Illustrator file. Make sure 1 equals 1 millimeter RGB. Hit OK. And once I've done that, I'm good. What I don't want to do is walk away from the file, because if I do, I have booleaned and done things I don't want to keep. So only thing I want to keep is this drawing. Control C, copy clipboard outside of Rhino. Undo. And I think that's good. Paste. And now I can save my, although I don't want to keep the original drawings in here because that's confusing. So before I paste, take these, group them and put them in storage. Then paste. file's updated. I ended the booleaning so I can use this later. Save it. And I'll actually save as revised. That's it. Okay. Thanks for watching. I'll see you in class.